So I'll be honest. When I was first asked to do a master class here during the quarantine, I was a little bit hesitant at first because I don't have a lot of equipment at home. That being said, when I thought about it, I have enough equipment at home, and I decided that I was going to work on um, a couple of things that I already had in process. But before I show you what I worked on and what I built, I want to just kind of talk about a few of the questions that people even ask around around this sort of thing. So it's the answers sometimes seem a little bit obvious, but it's worth talking about. Why technology? Why are we dealing with technology? Um, Technology is what makes our world go round. This is something that is ubiquitous during the best of times, and during these times, it's technology is even more important. Students at our school at Cats Academy Boston they start with the basics. They start with small electronics devices, small projects that they can conceive and design on their own, and then hopefully see through to completion. Working with these small handheld devices, such as an Arduino board that you see in the top right corner, we can kind of form the foundation for a lot of the things that students like to work on. And I'm talking about small robots. I'm talking about underwater robots, for which we have a club this year and next year too. I'm talking about wearable technology and interactive art, and just generally kind of contraptions and things that people can make for themselves. And you can do that starting with boards like this board up here, this Arduino board. And the type of skills that you learn during technology classes will easily later be scaled up to work on what you would more traditionally think of in terms of technology: hospital robots, airplanes, rocket ships, self-driving cars, robots that roll around on Mars by themselves. These are probably the first things that come to your mind when you think about technology. But we need to form a solid foundation, and we can do that at CATS Boston using the Arduino technology that is so prolific nowadays. Something that I learned early in my engineering career, because I was an engineer before I became a teacher, was that you don't have to know how to do everything, but you have to know that you can learn it. And so what I try to tell my students in my open source engineering class is just that. They might not know how to do something, but they think that they can learn all the basics that they need to make an idea come to life. And if you take that stance, you can get pretty far. And if you combine that with a lot of the DIY videos and the books and the magazines and publications and the experts at our school, you can keep asking the questions and keep on finding out the things that you need to know so that you can learn them, so that you can make your idea come to life. And what I really want students in my classes to do, especially in my open source engineering class, is to make what they like. Some people like robots. We will absolutely be making robots of this exact size and scale. We have loads of robotic gear that will help you build a nice sized robot to accomplish a task. Also, people love wearable technology. I take every chance I get to remind people that the skills that they learn in open source engineering can be applied to robotics, to a bit of technology that you wear on your hands or your face or your clothes or your hat, or they can be applied to anything that you put your mind to. So just because you're learning about one thing in class doesn't mean it can't be applied in many different ways, in ways that I can't even imagine. So make what you like. Okay, so I'm going to talk you through the engineering design process. It's an important thing to get our students talking about and using, because the process is the point. The process is how we get things done, and it's how we make sure that we are making the thing that needs to be made, and how we can make good decisions on our way to that thing that needs to be made. So I'm going to walk you through that during this talk, and I'm just going to show you how I defined the problem to make this thing that I made. How I kind of identified how it's going to work and what is going to constrain its operation, how I brainstormed the possibilities, how I chose the best solutions, how I prototyped the physical part and the electronic part, and how I tested it, and then how I improved it, and then how I communicated what I built. Okay. And also this iteration step, this step where we go back and improve something, that's maybe one of the most important parts of the engineering design process. The engineering design process is purposefully not a linear process. We don't just go from point A to point Z once and then stop. We're always kind of getting to a point and then realizing, hey, we need to circle back and refine that design a little bit. And so we purposely build in the ability to go back and revisit our selections, or even possibly revisit the constraints that we identified. Okay, so my project, the thing that I was working on at home during the pandemic with my limited equipment here, was to rebuild an old project that I had built, I don't know, 5 or 10 years ago. About 5 or 10 years ago, I had this this idea to make a light up bottle that that kind of glows in the dark. And it was basic. I mean, the hardest part at that point was to cut a hole in glass. I had to get a special drill bit. It worked in the end. I think I broke one bottle, but I had 5 that survived. And and I made this. I finished it. It was fine. I didn't love it. I didn't like how bright the lights were. I didn't like that it looked like a bottle with a bunch of lights in it. It didn't have the effect that I wanted. I wanted fireflies or light up insects in a jar, kind of moving in a lifelike fashion. And it definitely didn't do that. So these things sat on a shelf, unused, or in a box, gathering dust. And I never really did much with them. Further, they were inconvenient to use. They had a short cord. It was always hard to find a plug in the place where I wanted to use this. I was always struggling with that. So my idea was to rebuild this, and to try to build into it other advantages like battery power, no more cords, better lights, better effects, that kind of thing. Okay, so the first thing that I do when I start a project is I just kind of write down all the things about what is happening. So since in this case there is a current model, I just wrote down how the current model works, and then I wrote down kind of what I wanted for the upgrade. I wanted lights that are kind of lifelike. I wanted a rechargeable battery. I wanted some kind of on-off switch. And I wanted to be able to reprogram the lights without having to completely take apart the whole thing and start from scratch. So so these are kind of my rough list of features that I wanted to go into this contraption. And any student in my class for a design project would do something similar, especially to this right-hand column here, where you are getting the requirements or the ideas down on paper before you start building stuff. And so in terms of the engineering design process, this is defining the need and identifying the constraints constraints are what kind of hold your project within a certain kind of operating space or cost space or building ability space. And I made this list with the people who are going to use these things, i.e. Myself and my wife. We both kind of brainstormed as to like how we would use these bottles with fireflies inside them, and what kind of features we wanted with them. So this list of things is something that you do in cooperation with your customer or with your person that you're making this thing for. Okay, and then I made a rough sketch. Emphasis on rough sketch. You don't have to be a master artist to be an engineer. Trust me. If you want to learn how to draw a bottle, you should take a different class. This is a very rough sketch of a bottle, and all it does is it shows kind of where things are going to go. We have the body of the bottle. We have strings of lights on the inside. My idea was to build kind of an internal body, or a body that goes inside the bottle to hold the charging port, the power switch, and anything else that I need to run all these lights. Okay. Another rough sketch, but it's more detailed. This is that body. This is the body that holds all the electronics. And at this point, I was already kind of thinking about the parts, but I wanted to kind of at least get an idea of how and where things would go before I did some kind of final design. An important feature of the body or the chassis is that it would have an outer lip for the outside of the bottle, so that this body would not fall down into the bottle. It would have a charge port and an on-off switch. And then this is kind of an unexpected piece, but it has to go in there. There's kind of an electronic charge controller for this battery here. And without that, it won't charge. So I needed to add that in. And I kind of found that out later. I didn't know that I needed that, but after I started thinking about Arduino with battery and a self-charging feature, I realized that I had to have this fourth part right here, this charge controller. Okay, and then here's one constraint that I worked into the sketch is that this chassis, this piece, has to be small enough to fit inside the bottle. So we're talking about small parts, very small Arduino parts. Okay, and so here are some of the pieces that I landed on. These are next to coins, so you can see how small they are. Here's our power switch. This is our charge controller. This is our battery. Funnily, the battery is the biggest thing here. And this is our Arduino. This is when I had different nail polish. No, I'm kidding. Those aren't my fingers. So this is our Arduino, which is going to control the program for all of the lights. Okay, tools-wise, I just listed the tools that I needed for this. Parts that I had on hand already. I had a soldering iron, hobby knife, heat gun, wire strippers. I did not have a 3D printer, so I had to use the one from school. And everything else I already had. Wire, heat shrink, hot glue gun, and electrical tape. More parts. Okay, let me see. Before you start designing and building, you need to take measurements. This is part of, I guess I would say, part of the constraints process, where you're trying to find how large you can make your thing while still fitting inside the bottle. So I measured the neck of the bottle, and for the inside parts, I needed to round down so it wouldn't get too big. And for the outer part, I rounded up a little bit. Let's see, I think I see a question here. Okay, that's not a question. Okay, moving on. And then I measured all the components. Just to go back a slide, I measured all of these items specifically, just so I would know what I had to deal with there. So that's these measurements here. again, just kind of getting stuff down on paper. This is past the brainstorming process, but still getting information on paper so that you can have a source to work from. Okay, and then I made a plan. I started kind of playing around. I started playing around with with a schematic program that I have called Fritzing, and basically I found electronic. I found virtual sketches of all of my components. So this is my Arduino, my charge controller, my switch, and my battery, and I'm connecting them with wires. Again, you don't need to know how to do this. Okay. During our classes, I will walk you through the process of making an electrical circuit and how to do this kind of sketch. We'll walk through the function of LEDs or light emitting diodes, and we'll talk about how to build in power switches and how to choose the correct size battery for your project. These are not things that you have to know from the beginning, but you need to be kind of willing to open your mind to get there. Okay, and here's my circuit prototype. It looks a little bit hairy, but it's important to make an electrical device that resembles your final product, and it's important to do that so that you can test out the function of your circuit. Okay, all of these parts are kind of too big to go in the bottle, right? There's too much wire here. These LEDs are different than what are going to go in the bottle. This breadboard here is not going in, but the breadboard serves as a connection point for all of my main components, with the main components being the Arduino, charge controller, switch, and battery. And so this is a functional prototype, and this way I could test my hardware, and then I could also test my software. And I think, yeah, so I have a quick video here of my breadboard functioning. So the idea for this is that I will have strings of LEDs, not just individual LEDs, but strings of LEDs that will kind of fade on and then fade out and fade on and then fade out. So we get kind of a bit of a natural kind of glow up and then glow down kind of effect. And so I tested my software using this breadboard to make sure that it worked. And only after I had kind of a functioning breadboard prototype did I move on to trying to make this whole circuit small enough to fit inside the bottle. Cool. And don't forget the coding. Let me see. I'll let you in a secret. I'm not a master coder. I can do okay with code, but I have a lot to learn. And so a lot of this code was inspired by a project that I read about in one of my favorite magazines, and that's how I learned how to make two lights kind of be on and then one light fading up and one light fading down. I learned that technique from a different project, but I incorporated some ideas from it into this project. And then the challenge was, after I had that program running, I had to customize it to the board that I was using. So that small Arduino board is called a Trinket, and it is a little bit different than other boards. And so I had to write some special code to make it work for this project. So I always tell my students that, yes, we can get ideas from some certain places, but what I want you to do is kind of take the inspiration from them and then incorporate it into your project. So you might use a somebody else's project as a starting point, just to kind of get a technique going. But then you're quickly kind of learning from that and incorporating that into your much larger project. Okay, and then I had to make a 3D model that would hold all of my parts. So this is inverted compared to the final product, but it's the correct orientation for printing something on the 3D printer. Long story short is that I had some electronic versions or electronic 3D models of my components, so the Arduino and the charge controller, and I imported those into Tinkercad, which is a free 3D modeling software, and then I built this green thing that will hold all of those parts. It's basic. It has maybe I don't know, 10 shapes total. Have a disc down here, and then something to cut away from a larger cylinder. A couple of triangles here to hold the Arduino in place. So this is all just made from simple shapes, kind of cobbled together in a very functional way. This is all going to be inside the bottle, so the appearance of this was not so important as the function. Tinkercad is very easy to learn, and it's free online. Okay, and then I printed it. I printed the chassis here using our school's 3D printer. I happened to be borrowing the 3D printer because I was making masks, face shields that I then donated on the school's behalf to local hospitals that were in need of personal protective equipment. After that was done, I started building these parts for this project. Okay, so here's my completed 3D printed item. You can see it's going to hold the power switch. This is going to be the hole for the charging port, and I've already soldered on a couple of wires there. Okay, so here's the circuit, again, kind of partially assembled, but you can see I'm starting to solder the wires into the connectors where they go. And then here's my first completed prototype. This guy right here. This is the Arduino. Here's the battery, and then you've got a bunch of wires going down to LED strings. And my idea was that my components would be extremely compact. If I could get them all in the bottle in the skinny part of the bottle, that would leave the entire rest of the bottle for firefly effect, with no hardware kind of interrupting that. Here's another view of that. Sadly, that idea wasn't going to work because the compact form of this was too big to fit inside the bottle, with the main problem being the fact that the battery here was contacting on this side, and the plug for the battery, I'll go back one, it was this dimension right here that was just like a tiny bit too big for the battery. So this is the iteration part, or the iterate part of the engineering design process, where you take your initial idea and then modify it to make your prototype better, or indeed to make it work. Because your first idea might not work. Your first idea might just be too ambitious, or too maybe your measurements were inaccurate. Maybe there was something else going on. But don't be afraid to iterate, and I would encourage you to do that in a purposeful way, not in a haphazard way. Okay, I know some people don't like hot glue. I personally love hot glue because it holds things together, obviously. But more importantly, for a project like this, where you have very sensitive wires that were attached to a circuit board, I want hot glue to provide strain relief or to hold the wire in place without pulling it away from its electrical contact. So I used hot glue not just to hold things down, but to protect the wires and to give them more strength. Okay, and I tested that final form again, and it fit. So I fit the whole thing inside the bottle there, and there we go. And the final product. Let me see. So these are actually pictures of one bottle, but it's hard to see the effect. So I've got a video here. Okay, and so what's happening with the bottle is you can see the strings of lights turning on and turning off. What they do is they kind of fade in and fade out, as you might see a group of fireflies kind of fading in and fading out on a summer's night. And so this is the effect that I really wanted for this bottle, something that has a dynamic element to it, something that kind of draws the eye and then makes you go, huh, what's going on there? This is, to me, much more satisfying than what was happening with the early version of this bottle. Okay, so getting back to the engineering design process, let's talk about what we did. I defined the problem by by talking to the customer, i.e. my wife, talking to the people who are going to be using this thing and getting their needs, getting the problem that we need to solve, getting that into a specific form that we can then build something for. I identified the constraints by taking measurements, and I envisioned all of the different ways that I might use this. Maybe we use it outside around a campfire with friends. Maybe we use it inside for a romantic dinner. Maybe we use it during a holiday to light the pathway leading up to my house. Maybe if my nieces and nephews come visit, maybe they use it when they're making a fort or a playhouse or something. So these are all the different ways that this thing could maybe be used. I brainstormed by considering the many different ways that I could make this happen, and then I selected parts based on kind of what was available and what I could think work, and then I sketched out my ideas for it. And then we made prototypes, both an electrical prototype and a 3D model. We tested it to make sure that things would fit. We iterated once we found that the first version was too thick, and then I communicated my results by recording a master class here. And so it's this process that the students in my robotics course and in my open source engineering course will have to go through. They will need to do all of these steps to make their ideas come to life. And the great thing about this is that it works. This process allows you to walk away with a fantastic model that is something that came from you. This is not something that I told you how to make. This is not something that this is not a report that you're writing on something that's already been written. This is something that you conceived and built and learned great things along the way. And many of those lessons can be directly applied to whatever else it is that you're doing for your career. Okay, and then I just listed my part sources and my CAD file sources, but I'll go back to this engineering design process sheet. I'm also going to stop sharing my screen and show you a couple of the parts. See if I can do this. So I made several of these bottles. I made 4 of them so far. I think I have one more in me. I have an example of the Arduino that I used here. I have a very early prototype of the chassis that I made, which was very large, and then the final version of the chassis that I made on the 3D printer. Thank you.